Welcome to Microsoft Build 2017. My name is Kevin Lamb.
And I'm John Fancy.
Today we're going to talk about enterprise integration and hybrid in the cloud using Logic Apps. Let's go to the slides and see what we have. So what we're trying to do is show how Logic Apps is at the core of our cloud integration platform. Logic Apps provides business processes that are hosted in the cloud and built from the cloud. Around Logic Apps, we have API management and Azure Service Bus. API management provides the ability for you to treat your APIs as products and be able to manage them in a holistic way, as well as Service Bus, which gives you queues and topics and asynchronous messaging in the cloud. With that, you get a series of connectors and access to Azure services. With the slew of connectors that we have, we give you access to all of the SaaS capabilities in the cloud, as well as the power of Azure behind Logic Apps. So now it's not just about the Azure services themselves, but how you bring them together.
Okay, and it's not just about just the cloud, right? We're talking about hybrid here and enterprise integration. So we built a designer that you can use from both Visual Studio, if you're familiar with that, and that's your go-to dev tool, or use from the browser. The whole idea being that you can build integration solutions more rapidly, faster than before, and have more productivity than you had before. And as Kevin said, it's about how you take all the services and richness of these SaaS solutions and mash them up together to create integration solutions. And it's not just about that either. It's about being able to build mission-critical applications, enterprise application integration. It's like, how do I ensure that what I build is reliable? It runs, day in, day out. I don't need to give it too much attention. I can just rely on this thing happening without having to sort of sit on top of it the whole time. And that's what we built with Logic Apps.
Yeah, so our hyperscale workflow engine that's born in the cloud and doing your integration workloads has been critical to a lot of businesses today.
Yep.
So Logic Apps connects everything. So the ability for Logic Apps to reach out to accessible services out in the cloud brings a complete solution from either the SaaS connectors, where you can connect to things like Salesforce and DocuSign, including our own services like Dynamics, the B2B capabilities, where you can have built-in, out-of-the-box EDI, AS2, and partner trading management right out of the box from Logic Apps, as well as PaaS support. So Logic Apps is a serverless solution that allows you to not have to worry about scale, and the consumption model really gives you a flexibility in being able to deploy and start working with Logic Apps without having to pay for things you're not using. It also brings together the different services in Azure. So you can build smart, integrated solutions, and it's all about the better together. So the component parts, we have really great services in Azure, from Service Bus to SQL to the machine learning, but it's about bringing those things together in Logic Apps that really provides the value from that. So we have rich capabilities built into the Logic Apps designer itself, enabling you to reach out to things like API management to abstract your APIs, and we'll have a first-class experience for being able to look at those, as well as Azure Functions. So you can go ahead and orchestrate different Azure functions, as well as just call a piece of code right from your Logic App. Logic Apps is also about hybrid. So not only can it reach out to the cloud to different services and APIs, but it can reach to your systems on-prem. It can talk to your SQL server, your AS400, your SharePoint server. We have lots of connectors that are treated just the same as the connectors for connection to the cloud. You just connect through an on-premises data gateway, and you have access to those systems on-prem. So at the core of Logic Apps, we have an orchestration engine, but what really provides a lot of value is the abstraction to the different services we have through what we call connectors. All the connectors we have are managed connectors, and what that means is that you don't have to worry about the scalability or the connectivity. Those connectors provide a canonical abstraction across all of those services so that you can be worrying about just the business process as opposed to all of the message formats and the API nuances for each of those services. We have taken all those things away for you. With those connectors, that creates the abstraction to those different services, and then you create a particular connection to those connectors that provides configuration information, authentication or authorization information for your Logic App that wants to connect to it. And that connection is a resource that gets deployed alongside with your Logic App, and you can go ahead and roll and do separate activities across your connections than you would in your Logic apps.
Yeah, absolutely, and this is extensible as well. If you have to build your own API apps, they just plug right in too. So you can build API apps that act as triggers and actions as well as part of the Logic app experience. So you can bring your own code and really extend the platform as well.
And if you see this eye chart of connectors, it's kind of purposely put that way because we have over 130 connectors. Those 130 connectors are growing every week. And we want to call out some particular connectors, some that we connect to Azure. So we have a long list of Azure connectors that is continuing to grow. And we have connectors to Microsoft assets, from Bing to Dynamics to Office to SharePoint to Visual Studio, team services. So they're all there, access at your fingertips to build really great integrated solutions. So let's go to a demo. What I'm going to show you is going through Visual Studio 2017. We have a great experience in Visual Studio so that you can go ahead and build your Logic app right in VS. The way that we've done this is that because Azure Logic apps are an Azure resource, we went and integrated into the ARM project. So what we'll do is we'll create a new ARM project. So if you go and create a new project, and you can, from your cloud, pick an Azure resource group. So that's going to create an Azure Resource Group project. Click OK. And then you get an option of what resources you want to put into that resource group. So in this case, we're going to pick a Logic app. We say OK. And so now it's going ahead and creating that project with the ARM deployment template in it. And so what you see here is this logicapps.json, which is the deployment template. And if you look at it, you'll see that it's a simple ARM deployment with an empty Logic Apps resource. So what we're going to do is actually develop right into this template. So what you can do is then right-click. If you right-click on any ARM deployment template, then you get this option, if there's a Logic App definition in it, to go ahead and open with Logic App Designer. Let's go do that. So the first time that you're opening this, it's going to ask for some information about your subscription. And in this case, I'm going to pick my resource group and subscription. Then it has a place as you build connections to put those resources in. So in your first time experience in creating a Logic app, we give you a little hint and a little video to help you out. You also see a section here for common triggers. So these are ways to kick off a new instance of your Logic app. And then the following section has a number of templates that you can use to get started, or examine some patterns for seeing how other ways of integrating the different connectors can happen. So let's start with a blank Logic app. So the first thing you want to do with any Logic app is create a trigger. The trigger tells the Logic app how to instantiate a new instance of your definition. So if you look below, you'll see that we have over almost 150 different triggers that you can get started with. So that list is quite extensive. And so what we'll do is we want to do a smart SaaS one. So we'll do a Twitter search where we'll take that Twitter information, push that data into Cognitive Services, get some information out of those tweets, and then push that to a dashboard so then our marketing team or sales team can go and interact and understand what people are saying about their products or company. So let's pick this first trigger. And in this case, we're going to talk about, I want to see who's talking about MS Build. So now this is going to search for tweets that have MS Build in it. And so now every time one of those tweets gets fired, it's going to instantiate a new instance of this Logic app. And so the first thing I want to do is then I want to do some Cognitive Services on it to understand the sentiment of what the tweet is. So we have some great Cognitive Services that are available here at your fingertips. And here we have Text Analytics Detect Sentiment. So if I choose that one, this will now, if I pass in, what we have here on the right-hand side is a token picker. So all the outputs from the tweet that came in, tweet text. So now what this will do is send this tweet text to our Cognitive Services and figure out the sentiment of that tweet. You know, was the person happy or sad? Were they upset about what they're talking about? And so we can get some nice information from that. one of the other things we want to do is figure out what are they talking about. So it's not just MS Build. There's a subject or some keywords that are in there. So we also want to pull out some of the keywords that were in that text. So again, we'll go to Text Analytics, and there's an operation called key phrases. So again, key phrases, we'll pull out those key phrases from the text. So I'll reference the tweet text again. And so now we have a logic app that for every new tweet that comes in, will detect sentiment and pull out the key phrases. Now those key phrases will give me an array of phrases from that tweet. And so what I want to do is manipulate that array so that instead of having an array, I want it to be a string, so then I can pass it to some dashboard so they can make sense of what that set of keywords are. So we have some great array manipulation operations. And so you can see here we have the ability to create a CSV table or an HTML table. We can filter it, we can join or select across those arrays. So in this case, I'm going to do a join. And the join is going to be from the output of key phrases. And I'm going to join it with a comma. So now instead of having an array of key phrases, I will have a string of comma-separated phrases. Great, so that was really easy. So now that I have all this information, I want to be able to do something with it. I want to display it on a dashboard, and so I'm going to use Power BI to go ahead and push all that information from Twitter, going out to Cognitive Services, and then out to a dashboard. So we search here for Power BI, and we see that we have a Power BI add rows to data set. So I created a Power BI dashboard. So I'll go ahead and pick my workspace. And then within that workspace, I have a set of data set that describes the tweets, and then I'll pick the table. So now what it's going to do, it's going to go and interrogate my data set and table and come back and now give me a first-class experience for all of those properties that the Power BI dashboard is looking for. So we can see here that it's looking for the tweet text. So I can go ahead and put that tweet text in there. The key phrases. So the key phrases this time is the result of the join. So I get a string of comma-separated key phrases. The location. Here's a convenient way to go and filter out all of these properties. The time that this thing was tweeted at. The number of followers. We want to see how influential this person may have been. And then finally, and then finally the sentiment score. So this is what they felt about what they're tweeting about. So now we have this data being pushed to Power BI, and then here you can keep on going. So we can add a condition that if the score was less than 0.3, which means they were unhappy, go push that to my Slack channel to have somebody respond to that tweet and figure out what was going on. But let's stop there, and now we can go ahead and deploy. I'll go ahead and save and deploy. So, this is just an ARM template. So all this work that we've been doing is actually serializing itself to the ARM template. So you can see here in code view, the code behind all the stuff that I've just been doing has now been serialized in JSON in the background. And what I will do is go to my Solution Explorer, right-click on my project, and say deploy to my resource group. So here we have as a typical ARM deployment, you want to be able to edit your parameters, and you need to give the logic app a name. So this is my demo build tweets, and it's going to ask for a Cognitive Services key. I'm going to go ahead and save that and hit deploy. And so what's happening, if you can see on the bottom, is that it's actually going ahead and deploying that solution in the background, and it will take only a few seconds to go ahead and deploy that. So while that's deploying, one of the other great integrations that we have is in Cloud Explorer, so that's been successfully deployed. So if I go in Cloud Explorer, I had already built this and published it. We can go ahead and right-click, and we can actually look at the live published version, or we can look at the run history. So the run history is integrated right into Visual Studio, and then you get to see all of the runs that have happened for every tweet that has occurred. And then when you look at what a particular run history, you actually get to see the exact same view as you get in your designer, and actually see all the values for inputs and outputs to every step, so you can see what these folks are talking about. So you can see the sentiment score in this case was a 0.78, and the key phrases that came out, and this is in Spanish, CL hash. And then if I go to the dashboard, so I have this great dashboard. I go ahead and refresh it. And with the really simple dashboard, we have a world map showing where all the tweets are coming from, the sentiment score. There was one guy who wasn't very happy about this, and all the sentiments. You could see that last one that was in Spanish, right at the top there. So, in just a few minutes, you're able to build really high-valued solutions on top of Logic Apps, giving your business team great insights into your data. Let's go back to the slides. So enterprise messaging. So doing enterprise integration patterns is a really important aspect of Logic Apps, and doing enterprise messaging is a key aspect of that. Being able to communicate to various systems with different patterns, protocols, and message types. So the first thing that you want to have is different workflow patterns for how you actually deal with those different scenarios. So for example, the one common pattern is a claim check pattern. So there are many times where you have large messages and you don't really need all of the contents of the large message. You just need some metadata so you understand how to route it and do something with the results or the content of it and just pass it around, as opposed to having to pull it in and out of your Logic app. So the common pattern is to have a service bus queue message with the metadata and the actual content of the body as a blob, and then just have a reference to that blob in your service bus queue message, and that gets passed around through your system. The next pattern is try finally. So this is like a exception and catch scope, where it allows you to have a scope with a number of actions in it, and then if one of those fail, you get to react to it, either compensate the actions that have happened, or just deal with the error and be able to fail gracefully in that case. To do that, you can go into your code view and configure this run after, and you can then determine after a particular scope. You say in this case, the name of the scope was try scope. You say it's failed, and then that action will execute if that scope fails. This also gives you the capability of reacting to any one action failure. Then you can use this pattern, for example, in a peak lock scenario where if there was a failure of a message, you can go ahead and abandon that message that was in your peak lock.
Which is kind of important, right? I mean, goes back to what we were talking about earlier, that this is for mission critical stuff. So, it's not just about the happy path where you just build something, but it's about what happens when things don't go quite right. You need to respond. You won't want to lose messages, which is why we have these patterns available in Logic Apps that you can use to catch anything that happens inside of a scope. You can put a bunch of actions in there. If any one of those fails, you can respond to that and kind of compensate for whatever's happened, whether it's putting the message back in the queue or whether it's taking some other action. That's great.
And the last one for today is in-order processing. This is really critical for certain business scenarios where you have to process each of those orders and requests in order. And we provide mechanisms in the Logic app to ensure that you can be in order. One of the benefits of Logic Apps being cloud first built is that it's highly parallelized, so that every Logic app is actually running as many instances of that Logic app as possible. And so in this case, where you want to do in-order processing, you want to actually remove that parallelization and have only one instance of a workflow running at a time. So in most other systems, it used to be the inverse, where you typically run as a single instance, and then you have to do a lot of work to figure out how to parallelize something. In this case, now we have the opposite problem, which is a good thing, right? So we get cloud scale for free without you having to think about it. But the aspect of that is now you have to rein that in if you need to. So there's two places to do that. One is on the Logic app itself. You only want one instance to run at a time. And if you're working on a collection, or for each also runs in parallel. So if you pass a collection to a for each, it will try to run as many instances of that loop as possible. So instead, you want it to only run one instance of that loop at a time. And you can see how you do that for the singleton workflow. you go to your trigger and you set this operation options single instance on your workflow, or in the for each to remove parallelism, you set your operation options to sequential, and that's how you ensure that you have only a single instance running at any given time. Service bus pattern. So service bus is kind of like our key messaging pattern and connector that we have in Logic Apps. It's one of the connectors that we've put a lot of attention to make sure that it has great throughput and functionality and integration into Logic Apps. One of the common patterns for Service Bus, of course, you have asynchronous messaging with queues and pub sub with topics. But besides that, you want to be able to have control of how you read messages off those queues and topics. So of course, we have the easy auto-complete method if you don't want to have to deal with this, but most enterprise solutions want to have more control. So you can do a peek lock. And so what that does is allows you to peek at the message, which reads the message off the queue. You can do work on it, and then when that work is successful and complete, then you can actually complete that message and it will delete it from that. So in the meantime, nobody else can pull that message off the queue. It's invisible to anybody else until you either abandon the message, it gets put back on the queue, or something goes wrong, you get a failure, and then eventually that message will time out and appear back on the queue. The next one is a dead letter. So there are times when a message is just bad, and every time you process it, you will always get the same result, which is an error. So instead of having your message go back on the queue and having somebody else discover that it's just a bad message, go ahead and take that message and put it into a dead letter queue. And that's really easy with our, instead of doing a complete or abandon, you just say dead letter this message, and it goes to the dead letter queue, and you can have a separate process for dealing with all your bad messages. The next one, wait for next message timeout. So there's a common pattern where a message will come in and you want to do follow-on messages, or you want to listen for 5 messages or wait for 5 minutes, whichever comes first. So in that pattern, we have a action extension that allows you to put a limit with a timeout, and it takes a timeout parameter, and it will wait that long. If before a message comes back, that timeout fires, then you'll get a failure code that says it's a timeout, and then you can handle that timeout appropriately. Sometimes that's success for you, and that's okay. Correlation. So for doing patterns like asynchronous request reply over queues, you need to have correlation. So correlation allows you to send a message onto a queue and then wait for a particular response from that external system on either the same queue or another queue. But in this case, we will use the same queue where you can pass a session, wait for that message based on a session ID that you pass to it, and when it comes back, the logic app will continue again. So then this logic app will sit there and wait for that response to come back. And the last one is sequential convoy. So sequential convoy is for those who are familiar with BizTalk, was a great pattern that was supported by that system, and now we've enabled that in Logic Apps as well. And what that allows you to do is have in-order correlated sequences of messages that can be handled by your Logic app. So each instance of your Logic app will handle a set of correlated values and handle those in order. Let's go ahead and see what that looks like. So I'm going to go and switch off to my machine, and I will walk you through what a sequential convoy looks like. So here I have a Logic app, and in the first step, what I do is I'm going to do a peek lock receive off of a particular queue. And what's important here is that queue has to be a sessionful queue. So when you create that queue, there's a checkbox in Service Bus to say that this supports sessions. So make sure you use that. And then here, for the session ID, I want to say next available session ID. So what this Logic app does is for every new session that's not already locked, it will take that message, and for, let's say the session ID is session A. Now, no other instance of a Logic app can take any messages that have session A as its session ID. So that's locked to this instance. So then in the next step, it's actually just do work. In this case, what I'm doing is I'm routing that message to a topic that's based on the session ID. So then when we run this through, you'll see that session A messages are going to session A-topic, and session B will go to session B-topic. And so you can see how those things are routed. And then the next step is to complete that message in the queue. A couple things to note when you do a complete message. First is the lock token. So there's anytime you do a peek, there's a lock token that represents that message. And you also need to pass in that same session ID. So then Service Bus knows which message to complete and which session that you're talking on. So in the next set of steps, I'm going to do a do until either I get a message that has content done, or I see 3 messages or a timeout of 1 hour. So in this case, what that tells me is that I'm going to have in my case, I would have a sequence of 4 messages in a particular convoy. So then you follow the same pattern again, where you go ahead and peek on the queue, and you're going to use the same session ID that was initiated by that initial request from the trigger of the logic app, and say I'm going to listen to that same session. So this logic app will only process that session. Again, it will send it off to a topic. This is just your do work section of your logic app that will process that message. And then finally, you complete that message in the queue. Again, applying the lock token that you got from the read, as well as the session ID. One thing to note is that what I've done here is I'm actually using a trigger as an action in my logic app. So what that means, it will wait until the message is actually there in the queue. So that's all I wanted to show you, so that you can have in your back pocket a means by which you can do your own sequential convoy on your own.
And we have a template for this, right? So people can try this out themselves and see how it all works.
That's exactly right. So when we first created your first logic app, you saw that list of templates. You can pick the sequential convoy template and then get to see the same pattern on your own and start kicking the tires with it.
Great stuff.
Yeah,
Okay.
So there's one more thing. For Service Bus, we put a lot of attention to that scalability in Service Bus. So we have high throughput with Service Bus. Some things to note is that the trigger uses long polling. So the long polling means that we're waiting 30 seconds for each request that goes out to Service Bus. And if a message comes within those 30 seconds, we will instantiate a new instance of a logic app. What that means is that the minimum polling interval that you can have, or that you need for a trigger, is 30 seconds. So that all you're doing is resetting that long poll. And so then if you have a 30-second polling interval, you actually get immediate triggering of your logic app anytime a new message appears in your queue or topic. One thing to note is that the Service Bus connections are throttled at 6,000 actions per minute. It's important to note that these are actions per minute, and I'll explain why that's important in a little bit. So what are some patterns for how do you increase throughput, not only with the Service Bus connector, but with any connector that you're using? One is to use multiple logic apps sharing a connection. So then you can get multiple competing consumers across that connection. You can use multiple connections. So again, you get another pattern for competing consumers across that same instance on that connection. And then finally, each trigger can receive multiple messages in a batch. So this is where that throttled at 6,000 actions per minute comes in, because it's 6,000 actions, not 6,000 messages. So I can have a batch with 100 or 175 messages in it and do that as quickly as possible. So therefore, your pipe now becomes much fatter. And so what we've seen today in Service Bus Performance, I have one connection with a batch size of 1. I get about 6.5 messages per second. As I start increasing that one connection, a batch size of 175, I get 400 messages per second. You get 10 connections in a batch size of 175, you're at over 1,400 messages per second. That is hyperscale.
That's pretty good.
Okay, so let's move on to B2B.
Yes. So let's switch gears a little bit. So enterprise integration is all about these integration patterns and how do I implement this and this hyperscale message throughput against my integration solutions. But it's about much more than that as well. You know, we talked about hybrid, and we're going to talk about that a bit more. It's about things like B2B and traditional processing, like XML processing, using EDI protocols to be able to connect between your own company and trading partners. And for that, we have this thing called the integration account. Now, the integration account is kind of built into Logic Apps. It's in there in the Azure portal, and it allows you to upload assets that you may already have or can easily create create in Visual Studio, things like XML schemas to define those message types and be able to validate those, and as well as maps. You may want to be able to do transformation from one form of XML to another to change the shape of that, to kind of loop over that and do some work on it to get it in the right shape to send to a downstream system. And we provide XSLT mapping support for that, as well as graphical design, again, in Visual Studio, to be able to create new maps. And you can even upload existing maps that you have that are written in XSLT, either from existing systems you have, like BizTalk Server or something else, if you're currently using that. On top of that, we have, for B2B, we have the concept of trading partners and trading partner management. So what is that? Well, that's the way of me being able to model the interaction between two parties. So, this is my company and your company, and I create two trading partners to represent each entity, and then I can create an agreement between those two parties, which describes how we interact with one another. It describes the protocol, could be AS2, X12, or EDIFACT right now, and it also goes beyond that and says, well, what if we need to encrypt these messages? What if you need me to sign this message so you know that it's really coming from me? And all of that is all configured inside the integration account. And this thing is extensible as well. You can store your own configuration in here. It's just a JSON definition that we publish, and you can use the APIs to interact with that and write your own metadata into those objects and pull that out at runtime. So if you want to make some decision based on something about a trading partner, then once you know what the trading partner is, when you receive a file and we do that resolution for you, you can then look it up and drive your downstream kind of logic, the kind of conditional logic that Kevin showed, and go different paths depending on the configuration that you've set up. As I mentioned, this thing's easy to manage. We have a REST API. This is ARM template based again, so you can automate the deployments, you can add artifacts to your integration accounts, so you can do the synchronization between source control and your integration account, as well as having PowerShell support for command line access. And it's secure and scalable. So the certificates that you can use for the signing and the encryption, the secrets for those, remember this is the kind of public private key type certificates that you can use. The private keys we store in Key Vault with our integration on the back end. So you never have to have this stuff exposed in the logic apps themselves. We do the runtime lookup to retrieve that information and do that signing and encryption for you. And then the final thing I mentioned before moving on is disaster recovery. Again, in this business context, it can be super critical that you don't have any downtime. You're shipping trucks full of goods, and you need to meet your SLAs with your customers to keep them happy. And a lot of companies have very hard SLAs, no downtime, more than 30 minutes or 2 hours or something like that. And how do I meet that? So we built and shipped this new feature that lets you create two integration accounts in different regions and synchronizes those EDI protocol data, things like control numbers, so that you can actually fail over from one active primary node to a secondary and resume that logic app in the secondary node. So imagine you deploy a logic app to two different places. You can actually deploy it to more than two and have this active passive idea. And the primary node's running just fine and processing messages, and then you decide there's something not quite right, and you just want to activate or enable the logic app in the secondary region. It'll be ready to go because in the background it's been synchronizing between these two integration accounts all along. So you can have business continuity with this platform as well. Okay. Right. Yeah. So more about XML messaging and the B2B capabilities. So we have the ability to do XML validation and mapping. We can also do things to and from XML, conversion from flat files, things like CSV files. And some of these EDI protocols are flat file based like X12. And being able to convert from the flat file to XML, and then being able to convert the XML to other XML formats, and then being able to convert that resultant XML to another flat file to send out over something like FTP or file or something else, whatever you want. You saw the 100+ connectors that we have. You can send this out over any protocol that you like, apart from Twitter probably, because that's probably a little sparse. And then, for EDI, we have the built-in support with the actions in the designer to be able to encode and decode from these different formats. And what does that mean? Well, I can receive a file in one format, in X12, which is a flat file format, and convert that to XML. And then it gives me that rich capability, again, with the messaging actions that we have to be able to turn that XML into a different shape to send to another system using your schemas and the maps that you create.
That's incredibly powerful to be able to manipulate and change the shapes of the messages as they go through the system.
It really is, and and one of the great things is you probably already have this stuff. You probably already got XML and XML maps, and you can just bring those assets forward and use them in logic apps as well. Okay, so another important aspect of this is how do I manage all of this? How do I understand what's going on? You know, I could have hundreds of logic apps running thousands of times a day, emitting lots of data. So we built a number of features to help you with that. We have integration with Azure Monitor, and that allows you to use alerts. So you can set an alert up in Azure Monitor, and you can actually trigger a logic app from a logic app failure to do things like send you a text message via Twilio if there's a problem, or email or something else. A lot of flexibility in what you can do there. We can also push the data from the logic app, the telemetry information, all that rich run history information, and push that to storage, or push that to Event Hub, or even push that to Log Analytics, which is what Operations Management Suite sits on top of. And that has a rich schema to allow correlation between different events. So each action in a logic app as they run emits this information there, and you can pipe that to one of these locations. And if you pipe it to Log Analytics, it then becomes indexable and searchable, and you can write queries. And we even provide an out-of-the-box dashboard for B2B that shows each individual protocol, X12, Edifact, and AS2, and allows you to see, you know, all of the errors that you're getting, and drill very quickly down into that, right down to the logic app level, and see the steps in the logic app and understand, you know, what's failed. And of course, some of these protocols have acknowledgements, so we understand that as well. And if things are in a pending state because an acknowledgement hasn't been received in a certain time window, then you can use the OMS alerting capability to alert you when something's not quite right, and you can look into that.
And that's really cool, where you get to be able to look at a particular message and then infer the sets of logic apps that actually had an effect on that.
Absolutely, yeah. But that's not it. We also have the ability for you to add your own data items. So we have this thing called track properties. Over on the left-hand side here, I've got an example of this. You can add this to your logic app definition. Kevin showed the code view experience, which again is just a JSON template. And you can add to track properties things like order numbers. And this is just using a simple expression to be able to pull one of those data items out that's flowing through the logic app. It could be an XPath into an XML document, or could be a field in a JSON object. And just track that out as well. And we'll push that to wherever you want it to go. And you can make that searchable as part of your kind of DevOps or operations management experience as well. And I think the final thing I'll talk about is Operations Management Suite, the out-of-the-box support we have with a B2B solution, and the ability to create these alerts and also download messages. So you can go into the solution, you can understand where there's a problem, and then you can download the original messages that were received, and at different steps of the process understand what the acknowledgements were sent and whether there's a problem with the data format itself. And the one thing I forgot to mention is the ability to actually have your own API tracking as well. So on the integration account, it actually has an API you can call from outside of Logic Apps, or from maybe from a Logic App calling something else, like an Azure function. Call that API, and we'll track that data too. So you could instrument other applications which could reside on premises, because this is just an HTTP endpoint with a REST API, or somewhere else in the cloud, and create true end-to-end, you know, traceability and monitoring across the whole platform, and see all of that in one place. Okay, so let's have a look at some of that. Okay, on my screen here, I've got a few things going on. So I've called this B2B transformation. So I'm going to start off in a context which I'm sure is familiar to a lot of you. I want to receive orders, and I want to use the X12 protocol to do that. So I have a simple logic app here, which is going to receive a file over FTP. So it's going to poll an FTP server. It's going to decode the messages that it receives. It's just going to be a file in this case. And it's going to take the results of that, which is an XML document, and convert that to a canonical format. So I have a standard internal order format that I want to use, because I may want to send that to different systems, or have other systems creating orders as well. And I'll show that in a minute. And then I'm calling a child logic app. So I have the ability to call one logic app from another one. So I'm calling this second logic app called process order. And this process order logic app is right here. What it does is it receives the order and then uses an XPath expression to loop over all of the lines in that order, and then inserts them into a SQL database after doing some parsing, some of the data operations that Kevin was talking about, which creates it in a nice JSON object format, so I can just pick the fields in the designer. So it's very easy to read once I put this together. Somebody else can come along and look at this and they know exactly what's going on, right? There's no kind of voodoo here, there's no code, so there's really nothing to understand. You can see how the mapping works between each field and where they're going into my SQL table.
That's a great feature to add. We should have the Voodoo feature.
We should do. That'll be cool. Before I actually show you the integration account, I'm going to kick this off. So here I'm using an FTP client, and I have an X12 order. And let's just open this up, and I'm going to drop this into the folder that my Logic app is watching. So this is a flat file. It could be anything, right? Even if you're not familiar with X12, I'm going to point out some of the things going on here. I have the, who it's coming from. I have it's coming from Fabricam and sending it to Contoso. I have their, so I have their name and address, and I also have 3 line items. I have this small widget, a medium widget, and a large widget, and then I have the line items themselves. I have line item 3, and I'm ordering 126, which are $10.99 each. I'll just flip over to my SQL server as well and just show you that there's nothing in here. So I'm waiting for that file to be picked up and for it to be processed. And while it's doing that, let's look at the integration account. So here, this is what I was talking about earlier. I have schemas and maps that I'm consuming from my Logic app. I associate a Logic app with an integration account for this to work, and then I just use those actions that I showed, the transform action and the others, to be able to pick a map from my integration account. And then at runtime, it looks it up and then runs the map against the data that I pass in. I have certificates, and I also have partners and agreements. And the agreement is what specifies the protocol that I'm using. So it has a type of X12, and I can open this up, and I can see when I edit it that I have a whole bunch of settings. I have receive settings and send settings, and this allows me to determine whether I'm going to encrypt, sign, etc., whether I need acknowledgements, all of that good stuff. So let's just go back. I'm going to scroll over to the left-hand side. I can see this thing is already running. I can click on the running instance and see what's going on. And in a few seconds, I'm expecting it to complete. You can see it going through the process now. It's going through process order, which is calling SQL to add rows to the SQL database.
So you can call child Logic apps?
I can, and it's done already. Final step is it actually removes the file from the FTP server as well. So if I just pop back over to SQL Management Studio and run that query again, you can see that it's added the 3 lines, the small widget, the large widget, and the medium widget. So immediately you can see that we're taking advantage of the parallelization feature of that for each. They didn't process that in order, it processed them in parallel. Again, as Kevin said, you can do that sequentially if you want, but obviously things can run faster when you do them in parallel. Okay, so that's great. I have this awesome EDI processing capability. But a lot of people may have other customers who don't really understand those protocols. Maybe they've come along later, they're smaller companies, they don't have the infrastructure, the skills, even the people to be able to implement this stuff, even though we've made it really easy to do in Logic apps.
It's not that uncommon to have mom and pop shops that need to integrate with either some big supply chain or a larger store that they give their products to.
No, not at all. So in this case, I'm going to actually reuse that process order process because that's great. That understands how to parse the orders out and put them into a database. I'm going to go drive this from email. So I've got an email trigger this time, which is going to receive an email attachment. And that email attachment is going to be a picture. It's going to be an image of a piece of paper that I took. And let's just have a quick look at that. It's right over here. It's got my thumb in it, so you can see it's definitely a picture. I could use a nice beautiful one here, but you guys probably just wouldn't believe me that it was really doing what it's going to do. I'm going to upload this picture. It's going to scan out all of the text in this and arrange it with the output. What it does is it creates a JSON object with all the different areas. So it picks out the name and address, picks out the order details, including the line items. And then it is going to call an Azure function. We have great function integration. I can just open the function right here, but that's really just tidying up the output that I get from the OCR because I don't actually need all the data that I get back. I do a lookup of the customer. So, remember, in the traditional world, I probably have a relationship with these folks already. I've probably signed contracts with them and we discussed how we're going to set this thing up and done a bunch of testing. This is just an email that comes in, right? So what I want to do is look up and see whether they're an existing customer or not. And if they're not, I'll go down this path. So I'm just making a condition to say, did I find a row in a table, the customer's table? And if they're not there, I'm going to use a DocuSign connector. And DocuSign allows you to send out, some paperwork that can be sent over email for the recipient to then sign, agree, approve, whatever, even reject, right? And the Logic app will wait for that action to be taken and continue when the contract is completed, which is the next step here. And then it's going to add the new customer and go off to call that process order. But you notice I'm not actually using the nested logic app here. I'm actually using an API. So I fronted that, again, showing the better together story. I've taken API management and put that over the top of the logic app. And then I can make that process order accessible, not just from anywhere inside of my organization, but beyond that, and put the necessary controls and everything else that I need with that as well. So let's see this thing run. Should we see this thing run?
Yeah, let's see it run. Now, API management in front of logic apps is really powerful. It creates the right abstraction so that you can not have to worry about the detail. Each operation you have in your API could be a function or a logic app or actual code.
Yeah, so I am just going to create an email here, and I'm going to use my email address. So I'm going to send it from the guy from Fabricam to me. So you've all got my email address now, which is great. And I'm just going to say, please rush, and then send that in. And it's going to fire that logic app. So in a few seconds, I'm going to receive, hopefully, a contract, because it's going to look up in the SQL database, find out that I'm not already there, and then send me the contract to sign via DocuSign. Okay, let's see that. See what that logic app is up to. Again, I can scroll over to the left-hand side, and I can see that it's running. So the process is now going through, is received the email attachment, is unpacked that, is sent that to Cognitive Services, to the OCR, Cognitive Service Computer Vision, and is parsing out all of the text out of that image, and then sending it downstream through that Azure function to ultimately call that second logic app to, before that second logic app to send out by DocuSign. Right, and here it is. So back in my email, I've received a DocuSign notification that I've got a contract to review. So let's just open that up. And of course, I just don't have time to read that. I'm sure none of you guys do either. So I'm just going to take this 5-page document and just sign the thing so we can get on with it. I can drop in a signature, adopt and sign. And okay, that's weird. Sorry, there's no box.
There we go.
Right, and then just click down the finish button at the bottom. I don't want to sign up to kind of keep up to date with what DocuSign are up to. I'm just going to let that go. And then it's going to let that logic app continue. You can see already I get a completed notification. So DocuSign has noticed that I've sent the document back, I've signed it, it's completed it. So I can go back to the logic app and just let that finish off. And you can see it succeeded. Let's just quickly open that up. And let's have a look at the outputs very quickly. Okay, if I expand this, you can look at the output of the optical character recognition step. You can see I get back all of this great information, and this is why I use the Azure function to tidy that up. And what the Azure function returns is an order. You can see I've got an order, I've got a company name, I've got some other information, I've got the customer street, I've got who it's from. Obviously, I didn't have the person's email address in this thing. It picked it out of the document itself, contosoproducts@outlook.com, and then the order line itself. And then it went through the process of looking up to see whether they're an existing customer, sending them out over DocuSign, receiving a response back, and then adding the new customer and sending the order. So if I go back to my SQL database, I can run that again, and I can see that not only has it added a new order line, for the small widget that was on that paperwork, but also added a new customer, Contoso, and pulled out all the customer name and address information and put that in my database as well. Okay.
All right. Let's back to those slides.
Yeah. All right. So just to finish things off, we've talked a lot about enterprise integration and a lot about things like messaging patterns, EDI, B2B, the things you can do with Service Bus interacting with logic apps to get this massive scale that we're talking about. I mean, 1,400 messages per second. That's pretty good, right?
That's monstrous.
But we have a number of ways of doing the hybrid kind of integration pieces. The first one I want to talk about is the data gateway. This was shown earlier on, but we didn't talk too much about it, so let's go into a bit more detail. The data gateway is a client that you install on a machine on premises, and you can create a connection to a Logic app to use that data gateway, and you use the Gateway Cloud service to do that. So basically you create a resource that acts as a proxy to that data gateway running on premises, and then create a connection to the data source on premises, which could be SQL Server, SharePoint, SAP, Oracle E-Business Suite, Oracle DB. There's a whole bunch of these things. Even the file system, which I'm going to show in a second, allows you to access the local file system and read and write to and from that as well.
That's a very inexpensive and easy to configure option, since it's doing that reverse proxy.
Absolutely, yeah, and it's great for kind of data movement, data wrangling, as well as application integration. The second option we have, which I touched on, was API management. API management has a number of great features in and of itself. For example, SOAP to REST support. So you have existing SOAP APIs that are available on your systems on premises or between your systems on premises. You can reach down to those as well through API management. And if you want to run that over a virtual network or put it over ExpressRoute or a VNet or a VPN, you can do all of that as well and access your on-premises SOAP services from API management, and then consume those APIs, as I just showed, super easily from your Logic app as well. And connect to any backend API with any technology, because API management provides the features to do that very, very easily. And the final one is Service Bus. This is a great way of being able to do cross-platform messaging. API management has a set of APIs, including REST-based APIs, so again, just HTTP. So you can read and write to queues and topics from a Logic app, and then be able to access those and do the same thing via the APIs on premises as well. So a great way of doing cross-platform messaging to the cloud, to Logic apps, to move data around via messaging. Let's just quickly switch back to my machine, and I'll show a very quick example of how I could add functionality to write to a file from a Logic app. So I've got this process order. So let's just scroll down. And if I add a new steps, remember this is the generic one that both of those other two Logic apps are calling, and do add action. And I'm going to add this after the response step, which is kind of interesting as well, because I don't have to be done when I send a response back. If I type in file here and just quickly scroll down, and I'm going to look for create file. This uses our file system connector. And I'm just going to pick a connection, which is my build gateway. I can pick a folder path. So when I create a connection, I can give rights to which folders I want it to be able to see. I give a file name like, hello world.
And amazing. You can interrogate your current file system.
Yeah, exactly. I can just walk the folders that I have on my file system just on my laptop here. And I could put it, whatever I wanted into this thing. So let's just, I don't know, let's put the order number in there. Okay, and then save that down. Now, if I ran this again, what's going to happen is it's going to write each one of these orders to my local file system and create a file for each one of those. You see it's created a for each around that for me. So each line item that's in that, because order number is in an array that I pumped out of the earlier steps, it'll spin over that and write out a file for each one of those. So, super easy way of being able to integrate between on-premises and the cloud with just really no friction at all.
No, that was almost too easy. Okay.
Okay.
Awesome. Let's go back to the slides. So to wrap up, the call to action, go ahead and build some Logic apps. We've enabled you with some pretty powerful capabilities in Logic apps to go create some complex enterprise integration scenarios and try it out. And if you get stuck or want some more information, we have a bunch of resources for you, from either our documentation to our blog. We have a monthly webcast where we talk about new features that are coming out. And we have some great set of learning videos already up on Channel 9 on our Microsoft integration channel. If you have any ideas that you see as a gap, or you want to see Logic App support, go ahead and put it onto your user voice, and you can see that aka.ms Logic Apps-wish.
Great.
Okay, and that's it. Thank you very much, and have a great build.
Thank you.